Winsun, a Chinese construction firm, just used a robotic printer to raise a 5-story apartment block without hiring a single bricklayer. 2 technicians watched a screen while the machine did the rest. And that sounds like a construction gimmick. Until you understand where the money is. The industry surrounding large-scale 3D construction printing is projected to become a multi-billion-dollar market, and Chinese companies are positioning themselves at the center of it. Because this isn't really a story about printing houses, it's a story about turning construction into a manufacturing business. Imagine a machine the size of a small building, moving across a construction site, and extruding specially engineered concrete in ribbons, roughly 3 centimeters thick. Layer after layer, a wall rises directly from a digital blueprint. No traditional bricklaying crew. No wooden framing for every wall. No army of workers, moving from one task to another. Just a printer, a digital design, concrete, and a handful of technicians monitoring the process. And that creates a problem for an industry that was supposed to have already solved construction's biggest weakness. Modular homes. Modular construction promised to make building faster, cheaper, and more predictable. Instead of constructing everything outside in unpredictable weather, companies could build entire sections inside factories. Workers would assemble walls, wiring, plumbing, cabinets, and other components under controlled condition. Then trucks would deliver those finished modules to the site, where cranes would stack them together. It was supposed to be construction's version of the assembly line, and for years, it worked. But there is one problem. Modular construction didn't eliminate labor. It simply moved a large portion of that labor indoors. Workers still have to frame the modules. Workers still install electrical systems. Workers still handle plumbing. Workers still install cabinets, fixtures, insulation, and finishes. The factory protects workers from the weather. It doesn't eliminate the workers. And that's exactly the weakness Chinese construction robotics companies are attacking. Instead of asking, how do we build the same house with fewer workers? They're asking, how much of the worker can we remove from the process entirely? That's where construction 3D printing changes the equation. Think about a normal 3D printer. You give it a digital file. The machine follows that file and builds the object layer by layer. Now scale that concept up from a plastic object to an entire building. The printer doesn't need to understand the house the way a human construction crew does. It only needs the digital instructions. Move here, extrude concrete. Move there, extrude again, repeat thousands of times. The result is a physical structure emerging directly from software. And Chinese companies have spent years trying to make this commercially useful. Earlier systems often printed wall sections inside factories that still required transportation, cranes, assembly crews, and additional construction work. The newer approach is much more ambitious. Instead of printing pieces of a building and assembling them later, mobile systems can increasingly print structural elements directly at the construction site. That matters because every step you eliminate is another cost you potentially eliminate. And this is where the story gets really interesting. Because you might assume these companies are making money by selling houses. That's only part of the opportunity. The real business model has at least 3 powerful revenue streams. The first is the machine itself. A large construction printer isn't a cheap piece of equipment. These are industrial machines designed for developers, governments, infrastructure companies, and large construction contractors. The customer isn't necessarily buying one printer to build one house. They're potentially buying a fleet. Imagine a developer constructing an entire affordable housing project. Instead of hiring hundreds of workers and managing dozens of subcontractors, the developer can deploy multiple automated printing systems across the site. The printer becomes a capital asset, and for the company that manufactures it, that's a major upfront sale. But here's where the business model becomes much smarter. The printer isn't necessarily the most interesting product. The concrete is. Every time that machine operates, it needs a specially engineered printing mixture. It can't simply use whatever concrete happens to be available at the local hardware supplier. The mixture has to flow through the nozzle, it has to hold its shape immediately after extrusion, and it has to become strong enough for the next layer to be placed on top. That creates something much more valuable than a one-time equipment sale. It creates recurring revenue. Think about the printer industry. Selling the printer gets the customer through the door.
Selling the consumables keeps generating revenue afterward. The same manufacturer can potentially make money three different ways: sell the printer, sell the material, and license the technology. That third layer could become the most powerful of all, because construction printing isn't simply about owning a machine. It involves patents, software, printing processes, material formulas, structural systems, and specialized know-how. Chinese companies have built large patent portfolios around construction printing technology. If those technologies become widely adopted in foreign markets, licensing can turn.
A family might want a 3-bedroom house, but the government might want 2,000 affordable homes. A developer might need 500 apartments. A university might need hundreds of dorm rooms. A mining company might need worker housing. A disaster response organization might need shelters built rapidly. Those are much better customers for this technology. Because when you're building one house, saving a few days may not transform the economics. When you're building 500 buildings, saving months can completely change the return on investment. Speed becomes money. And labor becomes one of the biggest expenses you can attack. This is particularly important in countries where construction labor is expensive or difficult to find. A Chinese manufacturer can potentially design the technology and manufacture the equipment in a lower-cost industrial ecosystem, then sell or license that technology into markets where construction labor costs are dramatically higher. That's where the global opportunity becomes much larger than China itself. The Gulf states are especially interesting. Countries such as the UAE have already experimented with 3D printed buildings. Dubai opened a 3D printed office building in 2016, and the region continues to explore automated construction as part of its push toward faster and more technologically advanced development. The same logic applies to parts of Southeast Asia and Africa. If a region needs huge amounts of housing quickly, the value isn't just the concrete. The value is the ability to turn a digital design into a physical structure with dramatically fewer manual steps. And that creates another advantage: standardization. Modular construction already benefits from standardized production. But 3D printing can take customization and automation even further. You don't necessarily need a completely different physical mold every time the design changes. Change the digital file, change the path of the printer. The machine can produce a different geometry, without rebuilding an entire manufacturing line. That flexibility could become extremely valuable for developers. But there is a catch, and it's a big one. 3D printing doesn't magically create a finished house. A printer primarily handles the structural shell. It doesn't automatically install every electrical wire. It doesn't magically connect every plumbing fixture. It doesn't put a roof on every building. It doesn't necessarily install windows, appliances, flooring, or furniture. A printed structure still needs conventional construction work. And that's why saying 3D printing will completely destroy modular construction tomorrow would be wrong. Modular still has major advantages. A modular factory can produce finished rooms with electrical systems, plumbing, cabinetry, appliances, and interior finishes already installed. A printer can't currently replace every one of those processes.